Following on from the previous video, we got to this stage here where the volume up to B is given by this thing here. So remember, we are integrating from B to 1. We are integrating from B to 1. So what we're doing is we are moving along the y-axis, and each step of the way we would need to obtain the radius, which is given by this, and then quickly pi r square it. That will then give us the area of the disk. And so we're moving along the y-axis. Let's say y is here. Quickly pi r square it. That will give us the area of the disk, and then sum up all the disks. That will eventually give us the volume up from B to 1. So that's this volume here, from B to 1. So that's up to here. So that's this volume here. But then later on, we will need to take the limits as B heads towards 0. But then in the previous video, we got to this stage here where you square root a negative. But that still makes sense, because if you look at the natural log graph, let's just imagine y equals natural log of x, even though this y is different from this y. But let's just imagine y equals natural log of x. It will look like this. This here is 1. This here is 1. Remember, we are integrating from B to 1. We are integrating from B to 1. Notice that B is between 0 and 1. So B is really in this region here. This thing here is from 0 to 1, meaning that we are only stuck in this thing here. Well, so that means it's always negative. So that means that this thing here is always negative, and then you've got a negative, and this thing here always being negative, then the whole thing here will always be positive, because we are always stuck in the realm of 0, between 0 and 1, between 0 and 1. So we are always negative. So this thing here will always be negative. So this thing here, even though you've got a square root of a negative number, it still makes sense. Anyway, tidy this up. That will then give us this thing here, and then integrate it. Minus pi is just a constant. Minus pi here is just a constant, so take it out. So that will then give us this. So really, it's just a matter of us integrating natural log y. And this is something that you guys always forget. How do you integrate natural log of y? You've got to use integration by parts. Well, using integration by parts, we've done this before, so I'm expecting you to know how to integrate natural log of y. So we've done this before. If you're trying to integrate, we've seen this before. Let's say you've got y equals. So remember, this y is different from our y. This is something separate. This is just a reminder, and I'm expecting you to know this. So if you're trying to integrate natural log of x, you would use integration by parts, and it's blah blah blah, and it turns out to be this. So when you integrate this, it would give you this thing here. So integrate this, it will give you this. Okay, so use integration by parts if you can't remember it. Well, anyway, integrate this, that will then give you this. So now put this into here, and then into here. So when you put 1 into here, and then this thing here will then become 0. Put 1 into the y, that will then give you this, and then it's take away, and then you put b into here, and then that will then give you this whole thing here, and then put b into here, that will then give you this thing here, and then tidy this whole thing up. That will then give you this thing here. Remember, this is just a volume from B to 1, but then we want the whole volume of the whole thing heading towards 0. So the whole volume V, not VB, this is just a volume from B to 1. The whole volume of the whole thing is given by us taking the limit as B heads towards 0 from the positive side. So the volume is given by this whole thing here, and it turns out, so you can imagine this B here sliding towards 0. So when you slide B, when B heads towards 0, this thing here will become 0. It turns out that this thing here also becomes 0, which I will explain why later on. So it turns out minus pi times minus 1, that will give you pi. So the whole volume here, all the way to 0, turns out to be pi. The whole volume there is pi. But I need to explain why this heads towards 0. This here, we can clearly see it heads towards 0. So let's try and work out the limit of this as b heads towards 0 from the positive side. This thing here, it turns out to be 0, but let me try and show you why it equals 0. So hang on, we are trying to work out the limit of b times natural log of b. Take the limit as b heads towards 0 from the positive side. Okay, and remember we are sliding b towards 0 from the positive side only. It's not like we are heading towards 0 from the negative side. We are doing it from the positive side. That's why it's one side. That's why it's a one-sided limit from the positive side. Well, anyway, what's the limit of this? So in your mind, picture this graph: y equals x, natural log of x. Picture this in your mind. So as you head towards 0, from the positive side, this thing here will head towards 0. It will head towards 0. Natural log heading towards 0, you can see that it heads towards negative infinity. Now, in order for you to evaluate the limit of this, we will need to use L'Hopital's rule. Remember, these are your indeterminate forms. If you can get it into this, and then you can apply L'Hopital's rule to work out the limit of this. It turns out that we've got well, this thing here is very similar to this, but the thing is we can turn this into infinity over infinity. When it's 0 over 0 or infinity over infinity, you can apply L'Hopital's rule in order to work out the limit of this. Here we've got 0 times negative infinity. We can turn this into this, and this is just a trick we've used in the past in order to work out the limit. We would rewrite. This is a trick that we've used in the past many times in the past. We would rewrite this thing here as natural log of b divided by 1 over b. These two are exactly the same. This is exactly the same as this thing here, but just written differently because, hang on, because you've got natural log of b divided by 1 over b. That's the same as you timesing the reciprocal of this, which is b. So this is the same as this thing here, but just written differently. So this thing here is just merely a trick in order to work out the limit. So we would rewrite as this. Now let's check it. Hang on. So as b heads towards infinity, this thing here will head towards negative infinity, and then this thing here, 1 over x, looks like this. As b heads towards 0 from the right hand side, this thing here heads towards infinity. So you've got infinity over infinity, which is of this form. So you can apply L'Hopital's rule. So whenever it's of this form, you can apply L'Hopital's rule. So hang on. Applying L'Hopital's rule. So remember, L'Hopital's rule says that if you differentiate the top and then differentiate the bottom, the limit of this whole thing here will be the same as the limit of this. So applying L'Hopital's rule, so differentiate the top, differentiate the bottom. Now tidy this up. Hang on. So you've got one thing divided by another thing here. So tidy this up. That's the same as you multiplying by the reciprocal of this. So that's the same as you multiplying by the reciprocal. Tidy this up. That will then give you this, and then tidy it up again. That will then give you this. Now, when you look at this, I hope you can clearly see it's 0. Picture the y equals minus x graph. So it looks like this. As b heads towards 0 from the positive side, you can see that it's heading towards 0, and nothing breaks down. So it's legitimate. So the limit is actually 0. Okay. So going back to here, hang on. Going back to here, the volume of the whole thing is when you slide b towards 0 from the positive side. It turns out that this thing here is 0 as b heads towards 0. This thing here will be 0. So overall the volume is given by pi. So this whole volume here is given by pi. Okay?